For centuries, there's been this persistent idea, a story that just refuses to die. The idea that a human body can, without any warning, just burst into flames from the inside out. Today, we're not here to chase shadows or entertain myths. We are conducting a forensic autopsy. We're going to open the case file on the entire phenomenon of spontaneous human combustion, examine every single piece of evidence, test every theory, and account for every anomaly. Our investigation begins now.
Okay, so here's our game plan. Our autopsy is going to proceed through 10 chapters. We'll start with the mystery of the unburned room, look back at the very first recorded cases, then get into the nitty-gritty of fire science, and finally deliver the modern forensic verdict.
You know, every fire investigation, every single one, starts at the scene. And with these alleged cases of SHC, the scene itself, well, it presents the most profound and, frankly, perplexing puzzle you can imagine. To really understand the myth, we have to reconstruct the very environment that gave it life.
This line, it's a summary drawn from a whole host of historical case reports, and it really captures the central paradox, doesn't it? The reports describe a level of destruction that is so intensely localized, it's like an inferno was somehow contained within the victim's body, while the world just inches away remained strangely, almost impossibly cool. This right here, this is the core anomaly that has fueled speculation for hundreds of years.
So let's get specific. Let's walk through the classic case of Mary Reeser. This was in St. Petersburg, Florida on July 2nd, 1951. Investigators walked into her apartment and found a scene that just defied all conventional understanding of fire. Mary's body was almost completely gone. All that was left was her left foot, still wearing its slipper, a fragment of her spine, and her skull, which had mysteriously shrunken down to the size of a teacup. And this little pile of ash was sitting in the burned-out remains of a single overstuffed chair. But just a few feet away, a stack of newspapers, totally untouched. The ceiling right above the chair had some soot, sure, but the rest of the room was clean. This is the pattern we see again and again, this extreme, surgically precise destruction right next to pristine surrounding. This is the question, the fundamental investigative question. You have to understand, to destroy bone, you need temperatures over 1400 degrees Fahrenheit, and you need to keep it that hot for hours. We're talking about the conditions inside a professional crematorium. But these scenes suggest that those temperatures were reached without turning the entire room into a raging inferno. This apparent violation of the laws of thermodynamics is what gave birth to the SHC myth in the first place, and it's the one question our forensic analysis absolutely has to answer.
All right, so we've established the scene, this deeply perplexing scene. Now let's rewind. Let's look at the historical origins of this whole narrative. These early accounts, recorded long before modern forensics, were really the seeds from which the entire myth grew.
So the first whispers of SHC actually emerge in the 17th century, and interestingly, not as folklore, but inside medical texts. By the 18th century, these incidents were being collected in medical legal journals, treated as genuine, if completely baffling phenomena. Then you get to the 19th century, and that's the myth's golden age. It gets all tangled up with social anxieties, and finally in the 20th century, you have cases like Mary Reeser's, which get sensationalized by the media and bring the whole old legend roaring back to life. But here's the critical thing you have to remember. These historical accounts are profoundly flawed. They're almost always secondhand, they're not standardized, and they were recorded in an era that had zero concept of systematic fire investigation.
So, without any real scientific tools, early observers, they just filled that explanatory void with the concepts they had on hand. A person burning from within wasn't seen as a failure of physics, oh no. It was seen as a failure of character. SHC was blamed on moral corruption, and most often on chronic alcoholism. This idea that a body just saturated with booze could become a literal tinderbox. Other theories talked about an imbalance of bodily humors, which was a cornerstone of pre-modern medicine. These weren't scientific hypotheses, not really. They were more like pre-scientific projections of fear and morality onto the unknown. Okay, so we now pivot. We're moving from historical anecdotes to the non-negotiable laws of physics and biology. Before we can even start to evaluate any theory, we have to establish the baseline scientific constraints. I mean, what is a human body actually made of? And what does it really take to make it burn?
This number right here, 60%. This is the first and honestly the most significant barrier to any theory of spontaneous human combustion. The human body is, on average, about 60% water, and water has a really high specific heat capacity. What that means is it takes a tremendous amount of energy just to raise its temperature. So, far from being a tinderbox, the human body is an exceptionally poor fuel source. It actively resists ignition. It's designed not to burn.
Now, let's try to quantify the energy we're talking about. Think about a modern crematorium. It operates at between 1400 and 1800 degrees Fahrenheit, and it has to maintain that insane heat for 2 to 3 hours just to reduce a body to bone fragments. The SHC hypothesis, it demands that some unknown internal process can generate that same incredible amount of energy, and do it without a giant refractory brick furnace to contain and concentrate the heat. This presents a fundamental energy accounting problem. Simply put, where does the power come from?
And this slide, this gets to the absolute heart of the matter, the fire triangle. This is Fire Investigation 101. All combustion, without any exception, requires 3 things. You need fuel, you need an oxidizer, like oxygen, and you need heat to kick off the reaction. Now, the body can certainly provide the fuel, and the air around us provides the oxygen, but the shack hypothesis just completely collapses on that third point, heat. There is no known or even theoretically plausible biological process that can generate that initial burst of heat required to reach ignition temperature. You just can't complete the triangle from the inside.
Okay, so we've established the problem, right? We have a body that shouldn't burn, apparently doing so at impossible temperatures, and leaving this totally perplexing scene behind. But modern fire science provides the solution. And it's a mechanism that isn't theoretical. It's been demonstrated, it's repeatable. This is the wick effect.
So let me walk you through this. This is the wick effect, the scientific explanation for these bizarre fires. Step 1, you have an external ignition source. Something small, something mundane, and something that's often destroyed in the fire itself, like a dropped cigarette. It ignites the person's clothing. Step 2, the heat from those burning clothes starts to melt or render the subcutaneous body fat. Step 3, the clothing acts as a wick, just like the wick in a candle, and it starts soaking up that liquefied fat. And step 4, this creates a slow, low-flame, smoldering combustion. The fat-soaked cloth provides this continuous fuel source, which allows the fire to burn for hours and hours. This process generates intense, very localized heat, hot enough to destroy bone, while producing very little open flame that would ignite the rest of the room. And look, we've replicated this. Forensic scientists have done controlled experiments using pig carcasses. They have a similar fat-to-muscle ratio as humans, and they produce scenes that look remarkably similar to these historical SHC cases. So the wick effect provides a complete logical explanation. And yet, these alternative theories persist, mostly rooted in old myths. So, in this chapter, we're going to subject these popular ideas to some rigorous biochemical scrutiny and, well, we're going to dismantle them. Let's start with the big one, the idea that chronic alcoholism makes your tissue flammable. It's biochemically impossible, period. The blood alcohol levels you'd need to be even remotely flammable are many, many times the lethal dose. The real role alcohol plays in these cases is behavioral. It impairs your judgment, which makes you more likely to accidentally start a fire and less able to respond to it. Okay, what about other theories? A buildup of intestinal methane gas, or acetone from metabolic ketosis. They also fail. The quantities are just way too small, and the heat produced by our metabolism is orders of magnitude too low to trigger combustion. A static spark? Nope. It can't trigger a self-sustaining fire in human tissue. Every single one of these theories just collapses under basic analysis. Now we have to address that big objection, the one that SHC proponents always bring up. But no ignition source was found. This argument, it really stems from a misunderstanding of how fire actually works. It's mistaking a lack of visible evidence for evidence of absence.
This right here is a core principle of modern fire investigation. You have to understand that fire is a destructive process. It literally destroys the very conditions that created it. A dropped cigarette, a match, a spark from a faulty wire, these are small, transient events. In a fire that smolders for hours and hours like we see in the wick effect, that initial ignition source is very, very likely to be completely consumed. So the fact that investigators in 1951 didn't find the source for Mary Reeser's fire isn't some strange anomaly. It is the expected outcome.
But what about them? What about those few cases that proponents claim even the wick effect can't fully explain? We have to confront this idea of unexplained cases. But we need to look at them not as evidence for a new phenomenon, but as examples of a very specific and actually very common type of analytical error. This is a classic case of something called explanatory overfitting. It's what happens when we see a really rare event, and instead of just accepting that it was caused by a rare combination of ordinary factors, we invent a brand new, extraordinary cause. Think about it.
A unique combination of factors: a person's specific body fat distribution, the type of clothing they're wearing, the airflow in the room, the humidity. All of this can create a truly bizarre fire scene. But bizarre does not mean supernatural. It just means it's a statistically rare but entirely physically possible event. So, if science had a pretty plausible explanation, why did the myth of SHC persist so powerfully? Well, the answer doesn't lie in evidence. It lies in storytelling. This chapter is all about analyzing how media and literature amplified this myth, creating this parallel reality of belief that was completely separate from the forensic facts. Yeah, perhaps no one did more to legitimize SHC than Charles Dickens. When he depicted a character dying by spontaneous combustion in his novel Bleak House, he got criticized for it. But Dickens fiercely defended it. He fired back, citing real-life medical reports from the time. And in doing so, he conferred the immense power of literary authority onto a scientifically weak idea. You combine that with sensationalist newspaper headlines, and suddenly you've cemented SHC as a plausible threat in the public's mind. It's a classic case where repetition gets mistaken for verification. And that brings us to today. We now arrive at the modern forensic verdict, where science provides a conclusive answer that renders the entire category of spontaneous human combustion totally obsolete. You see, modern forensic techniques give us powerful evidence against SHC. Forensic anthropologists can now study microscopic changes in burned bone. And in cases that were once thought to be SHC, the patterns of cracking and warping they find are consistent with a slow, prolonged fire, exactly as the wick effect would predict. More importantly, they are fundamentally inconsistent with any kind of sudden, internal flash combustion. The bones themselves tell the story. And this table here shows you just how our understanding of these deaths has evolved over time. In the 18th and 19th centuries, a coroner might actually write "death by spontaneous combustion" on a death certificate. It was basically a label for the unexplained. By the 20th century, that shifted to the more cautious "death by misadventure." But today, the verdict would be accidental fire, ignition source lost. And that's not a failure to find a cause. It is a statement of forensic honesty and precision. So we have reached the end of our investigation. The evidence has been presented, the theories have been cross-examined. It is time to close the file and deliver a final, definitive verdict. Let's look at this. This table really summarizes the entire case against spontaneous human combustion. The idea of a spontaneous ignition from within, it violates the fundamental laws of thermodynamics, it violates the laws of biochemistry, and it's flatly contradicted by the physical forensic evidence. Now look at the wick effect. Initiated by a simple external source. Does it satisfy thermodynamics? Yes. Biochemistry? Yes. Forensic evidence? Yes. When one model fails every single test and the other one passes them all, well, the case is closed. At the end of the day, the mystery of spontaneous human combustion was never really about a paranormal phenomenon. It was always about how ordinary processes, a dropped cigarette, a piece of smoldering fabric, rendering body fat, how they can produce a truly extraordinary result under a very rare set of circumstances. It's not an unsolved mystery. It is a powerful lesson in scientific reasoning. The myth has finally been extinguished by the clear light of forensic science.